Hi there, and welcome to another college math video. In this video, we're going to continue looking at statistics. More specifically, we're going to start to look at measures of central tendency, ways to take numerical data and summarize it down to one central tendency. So we have two objectives here. We're going to look at mean, median, mode, and mid-range, which are all different measures of central tendency. And then we're going to solve problems about measures of central tendency. So we've already seen how data could be collected, how it could be visually represented, and now we're going to look at the numerical side of it, running and crunching some numbers, finding, okay, if we have all this data, what's one way we could summarize it? Because sometimes, depending on who we're talking to, too much information isn't what they're looking for. They want, summarize it, give me the key facts. And so here's kind of a few different ways we could do that. So these four different ways of finding central tendency. You've probably heard of a few of them before. You might already remember what they look like. We have the mean, which mathematically is represented as x bar, x with a bar on top of it. It's just a notation you may or may not seen used throughout the unit. And you find the mean by taking the sum of all the values and dividing it by the total number of data pieces. So I'll give you that description. The sum, this E kind of looking symbol is a summation symbol. It means the sum of X, all the data pieces, the sum of all the data divided by N, which is the number of pieces of data. Okay. The second measure of central tendency we have is the median. Again, you might remember this is the middle value when the data are in order. So it's very important for median that the data pieces are in order. If they're out of order, to find the middle piece doesn't mean anything. A special note about median, because this could happen. If you don't have an exact middle, but you have two that fall in the middle, then you'll take the mean of the middle two. If not an exact middle, take the mean of the middle two. There we go. So you have the mean, add them all up, divide by the number of data pieces. The median, finding in numerical order the middle piece of data, or the mean of the middle two, if that's the case. The mode, you might be able to guess this based on our other definition of modal class. This is the data piece that occurs most frequently. So this all has to be numerical data. So when you're looking at that list of data, if there's one data piece that exists way more than everything else, then you definitely have a mode. Even if it just exists more than everything else, you have a mode. But again, a special note here, it's possible not to have one. If every single piece of data is different, then you won't have one. And it's also possible to have more than one. So if you've got a large set of data and there's two numbers in that data that are showing up more frequently than anything else and the same amount, then you would have more than one. All right. One more note on these three before we do the mid-range. These three, mean, median, and mode, are all referred to as the average. So whenever data is presented to you, remember, you don't know how this data was collected. That's one thing that could have gone wrong. You don't know if the visualization of the data was made in the right way. And then if you're told that something is an average, you don't know which of these three computations was done. Sometimes there's good reason for picking one over the other, as you'll see once we start to go through these. And sometimes all three give you the same, but there's a choice involved. Even with finding an average, there's a decision to be made on which way you're going to find that average. Is it more important to have every single piece of data? Sometimes yes, sometimes no. Is it more important to find the piece of data that fell in the middle? Is it more important to find the piece of data that shows up the most? There's a good reason and time and place for each one of these three to be the selected kind. The more information is better. Having all three is the best. But imagine when news media is presenting information to you, they're not going to over-present data to you like this. Maybe that's how you feel, but in many cases, they're going to pick one of these as an average and then say, here's the average, but you don't know exactly which one they use to find it. And then mid-range, which would be a separate thing. They would say mid-range. This is taking the lowest and the highest value, adding them together, and dividing by 2. It's just finding the two ends of the spectrum and getting the middle of it. Maybe it's important as a means of a measure of central tendency to know what were the extremes and then kind of where does it fall in between those extremes. Maybe that's helpful. Again, a decision is made in all cases of being able to take the data and say, here's kind of its central tendency. You have 4 different ways of doing that. All right, so let's see it in action. So the data that we're going to look at on this next slide, we have a whole bunch of cities and some information for them, cost of living index and local purchasing power. Let me explain a little about these. So these indices are relative to New York City, which means that for New York City, each index would be 100%. If another city has, for example, a rent index of 120, it means rent is 20% more expensive than in New York City. If it has a rent index of 70, it means it's 30% less than New York City. So I'm not sure why New York City is the chosen baseline for this website. Again, the link is a little lower. You can, maybe it's kind of hard to see, but it's Numbeo, Numbeo. And I've given the link to this data specifically. But that website has so much data about countries all over the world and cities and everything all over the world. Really interesting data. So the two that I've chosen to focus on for this section are cost of living, which does not exclude rent. This is a relative indicator of consumer goods price, groceries, restaurants, transportation, utilities. It doesn't include accommodations like rent or mortgage. And again, if it's 120, that means it's more expensive than New York. And if it's lower, then it would be less than New York. And the other one, local purchasing power. This basically tells you how much you could get for the money that you have. Domestic purchasing power is 40. Again, 60% less. You could get 60% less than a resident in New York City with an average salary. So these are all cities in Africa. Again, this was just the choice I went with. And so right off the bat, you can see for cost of living there in order, Angola, Luanda, Angola, cost of living is 129. That means it's 29% more expensive to live in Angola, in Luanda, Angola, than it is to live in New York City. It's incredible to think that those kinds of things could happen, but these numbers show that it's definitely possible. So that's the data we're using. I won't always be able to reference back to it as we compute these numbers, but this is what you're using for these problems. Okay, so we're going to find the mean, median, mode, and mid-range of the cost of living data that is provided. So let's start with mean. Cost of living. Let me flip to my chart here. Cost of living is the left-hand column. It's labeled. So for mean, we add up all the data pieces and divide by the total number of data pieces. For this problem, I will list everything added up, but in the future, I'm not going to. And I don't expect you to, although it does help me to see what exactly you were thinking when you submit work to me. So we have 129, 62, 45, 44, 43, 41, 41, 40, 40, 39, 38, 37, 36, 34, 33. Crazy to think there are some cities with cost of living at 33, which means so much less than New York. So add them all up and then divide by the total number of data pieces. In this case, we have 16 data points. All right. I'm going to spare you the time of watching me type this in the calculator. I have already typed it in. Those numbers in the numerator add up to 740 divided by 16. And as a decimal, we will get 46.25. As a default, you can round to 2 decimal places. Just watch an online homework system might tell you a different number, but generally it would probably say 2 decimal places. So the average or the mean cost of living for these cities in Africa is about 46.25. All right, the median. Median is the middle value when the data are in order. So these data pieces are in order from top to bottom. If you count from the outside in, you'll see we don't have an exact middle. If there's 16 data points, an even number, we won't have an exact middle. We have 2 that are in the middle, and those 2 are both 40. They're both the 2 middle places. So basically we find the mean of those 2, which, surprise, surprise, is 40. The mode. This is the data piece that occurs most frequently. In this case, we have more than one. We see the number 41 show up twice, the number 40, and the number 38. All of these would work as an answer for mode. And finally, the mid-range. Take the highest and lowest, the 2 extremes, and find their midpoint. Add them together, divide by 2. So the lowest is 33, the highest 129. If you flip-flopped and wrote 129 plus 33, same thing. We get 162 over 281. So we've got 4 different numerical answers that are a measure of central tendency, a way to look at that data and say, here's one way to summarize it. Which one do you think has the best representation for this set of data? The truth is, there's really not a right answer. Depending on what you want to know, and if you're presenting this to an audience, depending on what you want the audience to think. If you want them to think that it's not that far off from New York City, you're probably going to present the mid-range and tell them, well, it's 81, that's pretty close to New York. If you want them to think that there's this vast difference, you're probably going to present the median. Look, the median value was 40. That tells us a lot. That tells us it's a lot different than New York. It just depends what your motivation is. So even when it comes to something like finding mean, median, mode, mid-range, these things that are very computational in nature, while these numbers are accurately computed, it's our choice which one we present and why, and how it represents the data is a little bit different. So keep that in mind as you see any piece of data. All right. One more example with me and then some practice. This is kind of a student application side of something like this. Haji needs a test average of 70 to pass. If Haji got a 52, 75, 80, and 48 on the first 4 tests, what does she need on the 5th and final test to get an average of 70? Poor Haji's been struggling a little bit, and she's just trying to pass the class. So if the class were only based on test grades, which probably is not the case for most of your college classes, but if that were the case, this is how you could find it. Basically, I would start out by saying, how could you find her test or her average for the class if we did know all of her grades? This would be a simple mean computation. You would add up all of the tests that she has, 52, 75, 80, 48, and the 5th test we don't know, and you would divide by the number of data points, so 5. And that would tell you the average. Well, what we know here is that she wants an average of 70. So you've set up the equation and then basically solve. It's your call what you do first. If you feel more comfortable adding these numbers up, that's fine. If you'd rather get rid of the fraction right away, also totally fine. I'm going to go ahead and get rid of the fraction. I'll probably do both of them. If we multiply both sides by 5, that undoes this division of 5. On the left, we have 70 times 5, 350. I'm sorry, on the right. On the left, I'm going to go ahead and add up those values. That gives us 255 plus the missing value equals 350. Continue solving, subtract the 255 from both sides, and we get 95. So poor Haji needs a 95 on the 5th test in order to get a 70 in the class. What would it mean if we got a number, what if we got 110? What would that mean? It would mean that it's not possible for Haji to pass. The computation doesn't know what it is we're looking for, but you as an analytical student would have to look at that number and say, oh, I can't get 110 on a test. That means it's not possible for this to happen. And sure, extra credit might be involved. I don't think so for Haji. All right, so that's really kind of the only variation we'll see here in these types of problems. We're more concerned with, at this point, just doing these computations, and then on the backside, analyzing if they make sense or which one would be the best choice. Okay, so the practice problems. You're going to find mean, median, mode, and mid-range for the local purchasing power index data. And then this information about Clémence. She wants a 90. If her grade is based on all tests and her scores are as listed, what does she need on her last test? So go ahead and pause the video, come back, and we will go through it together. All right, so let's see if we are on the same page. Let's start with our data at the top. When we find the mean for our local purchasing power data, add up all of the data pieces. I'm going to spare you writing all the additions. We get 945, again, over 16 since there are 16 data points. And when we divide, this gives us 59.0625. If we round to 2 decimal places, you can say 59.06. Okay, median. Again, we don't have an exact middle because there's 16, but what's important about this data is that it's not in order. In order for you to find the median, the data has to be in order. So you had to go through and number them or cut and paste and get them in numerical order. If you do that, then your 2 data points in the middle will be 42 and 45. Add them together, divide by 2, since we don't have an exact middle. We get 43.5. Then our mode. This is the data piece showing up the most frequently. Every data piece is different here, so we don't have one. And then mid-range. Mid-range, it's the extremes, the highest and the lowest data point added together. So 16 and 143 divided by 2. 159 over 2. 79.5. Okay, so again, just to kind of think through this critically, which one do you think would make the most sense to represent the data? Truthfully, I'm not sure any of them is really best. It would be your call depending on what you wanted to portray, but I think we can all agree that mode is definitely not the one. It does tell us something that all the data points are different, but that definitely doesn't summarize the data for us in any way. You might argue mean since it's kind of in between those two, but it really depends. Maybe mid-range tells us something that the middle of these two extremes is on the higher end. Maybe that's surprising. Lots of different ways you could look at the data. All right, and then our situation for Clémence. Clémence is the name of the first French exchange student my husband and I hosted. So I like to say it with an accent because that's how she said it, and so I can pretend I'm a little French. So she's shooting for a 90, and it's based on all tests. Here are the scores she's already earned. And there's one more she has yet to take. So what will we divide it by? She's already taken 6 tests, so should we divide by 6? No, 7, because we're going to have one more test in the mix. So dividing by 7. So we can get rid of that division by multiplying each side by that 7. We have 630. I'm going to go ahead and add them all up. We get 532 plus x. And when we solve here, we get x equals 98. So Clémence can do it, but it will be very difficult for her. Maybe not. She's gotten some pretty good test scores, though. One variation on this type of problem that you might see, and this could definitely happen as you continue on in college, you might see grades that are based solely on tests, and it might be the case that each test counts and then the final exam counts as 2 tests. I've definitely seen that happen. If that was the case, and Clément still wanted a 90, we would set this up exactly the same way, with one difference. Instead of adding that single test, oops, sorry, it's on top of me, we would add 2x. Basically that number, you could add x plus x, which is 2x. That test is counting as 2. So divide all of that by, in this case, it's going to be 8. We have 6, but then this one counts as 2, 7, 8. And so solve from there and you'll get the value that's needed on this last test if that's the final exam and it holds more weight than everything else, which is often the case. Okay, so in this video, we saw a little bit of the nuts and bolts and actually doing some computations, but I hope you've also seen that those computations still have some choices involved. You're deciding which one of those to present as your measure of central tendency. All things to keep in mind as you see any sort of statistical data represented everywhere. So I'll see you soon for another video.